Welcome to another in a series of How to Fly presentations produced by Genesis Flight College. This presentation is about how to fly an Rnav approach when the Waas signal is either not available or your nav system does not have Waas capability. For pilots who use the Garmin G1000 FMS, this situation is unlikely to be encountered because the G1000 provides an advisory glide path for all Rnav approaches. The only reason Genesis teaches this is to prepare students for the instrument flight test that must include a non-precision approach without vertical guidance, and hence we turn off the Waas to satisfy this requirement. What you see now is the situation where the aircraft is in the latter portion of a flight from Kitchener-Waterloo to Collingwood with an approach at Midland. You will no doubt notice the aircraft in the middle of the Borden restricted area, but that happened when I picked the latitude and longitude out of the air, and it turned out to be at that spot. Setting up the trainer display is a pain, so I left it as is. At this stage, approach clearance has been received. The aircraft is 5 minutes 23 seconds back from Bepper, so now would be a good time to call Unicom to indicate starting the Rnav 34 approach in 5 minutes via Bepper, and of course you would add an ETA to the threshold. But there's something wrong with this picture. The time to top of descent is 24 minutes, and the top of descent is over here. And this illustrates a very common mistake: failure to activate the approach when the initial approach fix becomes the active waypoint. So here it is. The active waypoint is Bepper, and Bepper is the initial approach fix. If this had proceeded unchecked, the pilot would have reached Bepper and then turned to go to Midland instead of going to EBGAX. The time to top of descent is therefore correct, because as far as the G1000 is concerned, it's going to Bepper, to Midland, to Collingwood, and then start the approach, and therefore the top of descent is over here. Once you activate the approach, this is what you see. The top of descent is only 3 minutes and 10 seconds away, and the distances here are leg to leg, but I will switch that to cumulative soon. The trainer is as annoying as the sim, with its tendency to have default settings at odds with what the operators normally use, and cumulative versus leg to leg time is one of them on the trainer. Data for the original flight plan disappears when you're now navigating through the approach, and only partial information is displayed here for VNAV profile. When you have a flight plan that contains a blue number, then VNAV starts to calculate, and it doesn't matter where you are, it will be calculating the time to top of descent and so on, appropriate for the applicable blue numbers. And only partial information is displayed here until the top of descent, or correction, until 1 minute to the top of descent, and then these boxes get filled in. And notice that the flight path angle is 2.5 degrees. And this is the parameter I was talking about. The angle normally selected by the FMS for a DA40 is 2.5 degrees. This is the particular parameter that is defined by aircraft type. And a DA40, for instance, or a correction, a 42, would have a 3-degree flight path angle set for the VNAV option. And if you want to use VNAV, you must set parameters before selecting VNAV, or else you probably forget one of the most important ones. The current altitude blue numbers include the final approach fix, GAIDS, because the approach does not have vertical guidance. As I've noted in other videos, if there is vertical guidance, VNAV can only take you as far as the waypoint immediately prior to the final approach fix. If there is no vertical guidance, then the final approach fix itself is added with a blue number. Notice that the approach plate would have you intercept the CDA at 2,400 feet, the absolute minimum. This is not a particularly efficient way to accomplish an accurate transition from level flight to descent because there is too much happening at that point. You could get away with it if you were flying a fully automated FMS complete with auto throttles, but for our less automated flight controls, the separation between the CDA intercept and the final approach fix passage is essential. A longer descent path would also help to really get the rate of descent nailed by the time you reach MDA. So we will change the CDA intercept altitude and clear the FAF altitude. A reasonable intercept altitude would be 2,900 feet. That's about 500 feet above the absolute minimum. That's what I usually choose. And that 2,900 feet would occur at just under 7 nautical miles. Now see, the CDA slope is 3 degrees. And that means you lose about 319 feet per nautical mile. At 7 nautical miles, the CDA altitude is 40 feet, and our altitude, 2,900 feet, is 140 feet lower. 140 feet is a little under 1/2 of the 319. So this CDA intercept would be about 6.6, maybe 6.7, so I just called it 6.6. I found that adding 0.2 nautical miles to the start point gives a more accurate CDA acquisition. Considering the time to transition to descent, starting descent at 6.6 with no additive will normally automatically make you high. So start down at 6.8 and you will be on a more accurate path. So you want to change the EBGAX altitude to 2,900 feet. You get the cursor active by pressing the FMS button, highlight the altitude, turn the little FMS knob to display 5 digits and then set 2,900, and then you press enter. You will notice that the size of the text changes when you change the blue number. When the blue number comes out of a database, it's smaller, and when it is manually input by the operator, the text is larger. And you want to get rid of the blue number at the FAF. You do it by highlighting it and selecting clear, and then when you're asked if you want to get rid of the altitude, press enter. If you don't, Rnav will take you there because Rnav remains active until the last blue number is reached. So even if you've leveled off, you're in altitude hold mode at 2,900 feet, and that's displayed on the scoreboard, VPath capture is still armed or even active. And in this scenario, with EBGAX being at 2,900 feet, Rnav could deal with the gaze altitude in one of two ways. One is you would be leveled off at 2,900 feet in altitude hold mode, and the FMS would establish a new top of descent to go down to Gades at 2,400 feet. You would arrive at Gades though on a 2.5 degree flight path angle, and you will level off at 2,400 feet, neither of which are what you want. You want to arrive at Gades on a 3 degree flight path angle, the equivalent of the CDA, and you don't want to be leveling off, and that's exactly what Rnav will do for you. You can get around it by some fancy button pushing, but it is far too easy to mess it up and ruin your approach. So right off the bat, get rid of the blue number and give yourself more time on the CDA by starting down at 6.8 nautical miles with a rate of descent that will give you a 3 degree CDA. You also want to check that the MSA at the initial approach fix is not violated. So in this case, the MSA is 3,300. So this advisory altitude here lets us know that we won't even be close to MSA. But there are some approaches where you could go by the initial approach fix at less than MSA, and that's obviously illegal. Check the time to top of descent. Or correction, yeah, that is top of descent. If it is greater than 5 minutes, you know that you will have to confirm your continued intention to use Rnav by pressing the Rnav again once you are inside 5 minutes to top of descent. So the next thing you do is you set the selected altitude to 100 feet below the desired altitude. So we want to go down to 29. The best we can do is set 2800 here. Then you want to select Rnav and immediately check that vertical path capture is armed. The next thing that is going to happen is you will hear the oral alert vertical track, and you will see the top of descent within 1 minute banner appear. And you immediately check to see if vertical path is flashing. Right now it's white on a black background. If it's flashing, it will be black on a white background. And the next thing you do is you check to see that you've selected the altitude select correctly. And if you have, then the only thing remaining that could be wrong is that you need to reselect Rnav because your initial selection was outside of 5 minutes from top of descent. When a VPath is flashing, one of two things is wrong. Either the selected altitude is not set correctly, or Rnav needs to be pressed again because you initially pressed it outside of 5 minutes. So if you check the altitude and it's okay, then it's got to be the Rnav outside of 5 minutes. So pressing the Rnav confirms. If the selected altitude is incorrect, then by turning the altitude set knob to set the altitude correctly, that will also stop the vertical path from flashing. And then you want to have a look at the other indications on the PFD and the MFD for that matter, that the top of descent is within 1 minute. So up here, Rnav data, the V appears in this box and the vertical deviation appears. 2 dots is 1,000 feet, so this is pretty close to 500. And sure enough, the vertical deviation is in fact 430 feet. The airplane is 430 feet below the vertical path. This caret indicates the rate of descent that you would have to fly if you were going to get to EBGAX at 2,900 feet. And that appears to be probably less than 400 feet a minute. There's 0, there's 500. And sure enough, the vertical speed required is 359. The Rnav altitude is displayed in magenta up here. And in the profile box, these two boxes are filled in. The time to descent is exactly 1 minute. The angle is 2.5 degrees. And here, the vertical path is being captured. This was actually flashing, indicate that the capture process is in progress. The Rnav altitude becomes your selected altitude. And the descent continues. You've gone past Bepper, you're on your way to EBGAX. You are now on the approach track, and a new altitude minimum is applicable. And you want to slow to reasonable approach speed so that you will be slowed down and ready to fly the glide path on speed. The bottom of descent alerting appears, and the barrel minimum appeared. That actually was a few seconds previously. It appears 2,500 feet above this number, so that would be 3,600 feet. So that was maybe 400 feet ago that this box became visible on the PFD. now you're in the turn at EBGAX, so you're just going by it. The altitude hold is just capturing 2,900 feet. You can see it's sitting at 2,910, so pretty soon it will be right bang on. And at that time, the vertical path caption will disappear. The track has flipped, but the bearing pointer is still pointing at EBGAX, and the target waypoint has not changed. It's still EBGAX, and you're 0.2 nautical miles away from it. Here you are rolled out on final, just after completing that turn. And you're looking for three things at this time. You want to see that the type of approach has replaced terminal here, so we're doing an LNAV. We expect to see LNAV. You want to make a radio call stating your time to the threshold. There's no point in calling the distances. Will be roughly 10 miles. Anybody in the circuit will not be able to see 10 miles, so a time to threshold is more appropriate. And normally you would check that you have selected approach mode and the glide path capture is showing up here as armed. But in this case, no Waas, no glide path, and there is no benefit to be gained by selecting approach mode, so just don't bother. Here, it's shortly after that previous slide, you want to set the altitude select to your MDA. Do it now so you don't forget it. So here the MDA is going to be 1100. You put that in the box, and now that is complete, and you can select VS at the appropriate moment when you want to start down. So what rate of descent are we going to use? Well, the MFD was showing a ground speed of 80 knots. So we look over here, and 80 is about halfway between here, and that would put the rate of descent at 425 feet per minute. So you would, at the moment you start down, you would select VS and select a rate of descent of 400 feet a minute, and then you would expect to go high eventually and have to make an increase at some point in the future. So we talked about starting down at 6.8, and I started down at 6.8, but by the time I got this screenshot, after all the button pushing, I was at 6.7. So that just illustrates the reason for picking that 0.2 buffer to get yourself started down in order to be accurately on the vertical correction, the CDA. So here's our first CDA check at 4.9 nautical miles. We wanted to see 2400, so 2410 is pretty good. There's the next check at 3 miles, but we knew we were going to go high, and we actually wanted to see 1770, and we're looking at 1900, so that's 130 feet high. So better make a rate of descent change. We'll pump it up to 500 feet a minute. And at the next point where we check at 2 miles, we wanted to see 1450, and it's actually 1540, so we're 90 feet high, but we're correcting. And by the time we get to MDA at 0.9, we're right bang on. That's what the CDA chart said, 1100 feet at 0.9, so we've made it exactly. So a word about leveling off at MDA or going missed immediately. You do have an option. Going missed immediately effectively makes an MDA a decision altitude. So you can treat it that way in the situation, say, if you were expecting to not see the runway environment, either due to a reported cloud ceiling or visibility being too low to see the runway in time to make the landing safely. So you could go missed when you hit MDA. However, it's extremely important you understand you may only climb straight ahead until reaching the map, at which time you may turn according to your missed approach instructions. And given that the instrument flight test guide specifically states this is okay, you could immediately go missed to avoid the potential for messing up the whole approach by going below MDA. And that can easily happen on a bumpy day when you're flying a no autopilot airplane and you're trying to hold level, you're trying to see the runway, and it's just a way safer and easier to go miss immediately and just tell the examiner that you had no possibility of seeing the runway or landing safely, so you decided to go missed immediately. And that is the end of the presentation.